Alright, so in this video we're going to talk about this tank filling system, and we currently have logic for it, but we're going to change that to an SQO, which is a sequencer output, and have that control it as well, rather than just standard ladder logic like we have right now. Now currently you see I have the E-stop pressed, so if I pull out the E-stop right here, the stop button is active, and then if I hit start, you can easily see that the system does start. Now I'm tracking the tank level. The tank level is like, I can have like a low fill, slow fill, whatever the case may be. Right now I have it at 5 for like a fast fill, and then once it hits a certain point, a threshold I should say, 2300 between 2500 is going to go to 2. So it's going to kind of minimize this valve and the flow that's in the tank, and just to show you how that works real quick. And then we'll proceed to making this a SQO. Now what we can do in the interim, in between now and then, is we can go ahead and add the rung and have our SQO there. We'll just put that in there, and our array, we'll call this we'll just call this batching. Let's just say batching state. So we'll call that batching state. For the array, let's just say the destination. Actually, I want batching SQO. Let's just call this SQO array. And then we'll give it a basically a dimension of however many we want to be able to be used. In this case, I don't see any more than like 10 states for that matter. So we'll give that a name. In here, we're going to do our mask, and the mask again is coming in saying, do you want to mask any of the states? We don't want to mask any of those states, so we're just going to call this SQO 0 compare, and then basically we'll have that all together, right? So we'll look at this, go to this right here. Well, we're going to type in a -1. A -1 gives you all the bits, because we're not trying to mask anything. So we're basically just having all the bits that we're passing through and saying, okay, well, we'll use everything. Not a big deal, right? So we have that. The destination, this is going to be the batch, we'll say batching state. And we'll just give that a name like that, and to be done with it. The control, we're going to call this batching SQO control. Just doesn't have to be anything, you can name it whatever you want to. This is the control of the actual system itself. So the length, again, we can go down and say however many states we want. To be honest with you, we're really filling it up. We're going to a slow fill. So we have an on, which is the system on. We have a system off, which is the E-stop. But the system on is one state. The second state would be controlling, let's just say, the output valve. And then the output valve controlling two. So I would say, and then we have the output, or the input valve, and then the output valve. And so let's just say right now a length of, let's just say a length of 6. And what we want to do is we're definitely going to put some control in here. Currently we don't actually have any control, so but we will. So as far as this goes, we'll just put in some favorites and stuff like that. Come in and let's see if we can drop that down. Let's just see what, we'll do bits. So we'll do an examine open, and then we'll also do a ons. So I'm going to call this batching station on. So batching, I'll just call this batching, station ons, and then we'll give it a dimension of however many we want to use. Let's just say 10 for the instance of what we're doing. and I'll change that because it spelled station wrong, which happens. So there we go. All right, so we do have that. So first we're going to one-shot this, and we'll come in and use the very first one. This is going to be start, so we'll do the start, and we'll index the start one time. So we'll just say, okay, if the system is started, what we want to do is obviously come in and allow the system to start. Now the next thing we want to do is actually we want to put some information in our array, because our array is going to be pointed to that. So let's go ahead and put some information in our array, and let's see if we can drop that down. So state 1, state 2, we're just going to keep it simple, state 3, state 4, state 5. We're going to use it very simple. You do not have to use it like this. You can turn on multiple bits and multiple things. I'm keeping it really simple so that it gives you the very easy comprehension of what the functionality does. So now we will have information all the way up to what we're using. So if it's started, right, so we're no longer going to use the start bit. We're going to use the actual SQL, the state, batching state, right? The batching state of 1 in that case. And that would be, if you look right here, that would be right here. It would be this bit right here. Now, we can say equal to, or whatever the case may be, but in the case of, we can actually go in and change that to, if we want to use like bit 1, for instance, we could use bit 1 and then not use bit 2 and then have it just like that. Or we can come back and actually, have this looked at, and then go, let's just say, for instance, we can say this is 1, make sure this drops down again. Let's see, collapse this real quick. This is 1, 2, 4. We could do, binary coded decimal to keep it really simple. 32, and then 64, and then 128, and then 512. So we can do binary coded decimal. Again, this will be using that first bit right there. So that's going to be using bit 0. So we'll look at that, but in the focus of what we're doing, you'll see the output come out. So what I want to do is actually come in and at least show you the very first function, right? So if it comes in and the start is actually on, you're going to come in and see. And then what we're paying attention to right here is the state. So it's in position 1. And we want to monitor the state right here. What is the current state that it's in? And we can use the drop down for that. So, and we're using, again, 0. So what we can do is we can come in here and say, okay, well, we want to stop this. As soon as what we're going to do is we're going to allow this to completely finish out, and then we're going to stop it before it does anything else. And then we'll go ahead and add the controls in here to make sure that that is working adequately. Again, some of these videos, like I say, I try to keep them short, but when it comes down to it, the point of what we're doing is to learn. So it takes what it takes, and that's just part of it. Okay, so we're going to hit the stop button real quick. So the start's not on. And what we're going to do is we're going to come in here and say, for this matter, we'll come in here and add a bit right here, and we'll call this system started. And then what we're going to do is we're going to alias this over to that bit that we just, so we want to alias. And this is where the SQO like really comes in like power, is you can do an alias just like this and just say, okay, I don't want to do the stop, or I don't want to do the start. Now in the sequence, like the way a sequencer is built, you can come in here and like if a e-stop is pressed or something like that, you can just write the position back to 0. You can, so for instance, like right here, what we can do is we come in here and add another level and come over here and change the sequencer position, which is the control. So we can come back in here and do like a move or something. And for this matter, I'll just, to keep this simple, I'll just change this right here to a move. So we'll come in and do a compare, or see a move right here. So we'll come in and change that to a move, and we'll do the actual control right here, and we'll control the position. This is actually, we want the control, so this is right, yeah, that's what we had. This 4K monitor is a little bit different, so anyway, so right here we'll just say that's a 0. So if the e-stop is pressed, or if the stop button is pressed, so we can say e-stop or stop button. So we'll have both if you want to say, so we'll say, okay, if the stop button is pressed, and or let's just say for that matter, oh, I didn't mean to grab that. So we'll come down here and do the start, or the e-stop button. And for this matter, what we'll do is we'll control that bit to go back. And then this should effectively clear. So we've effectively changed and cleared that. So this is batch state in the destination. The batch state is what we should actually change. So the batch state, that's what we should write to a 0. I was looking at that a little bit wrong, so hopefully that cleared that up. And so we want to clear that if there's any kind of stop button or e-stop or whatever the case may be. You can see if I hit a e-stop, the flasher does work. Okay, so now we have that in there. Alright, so we have the functionality is there for that. Okay, so we're saying if it starts, we want to have that. And what we'll do is we'll come over here and now change this right here. So every bit that we changed that used to use the start light, for instance, we'll do that. And that we'll have this fill timer. Fill timer is good, but the fill timer, we'll say if the fill timer's, if the start is on and this is off, let's just say we want to go ahead and let's just look at this. This rung needs to be, up here to make that a little bit more user friendly. Because what we're trying to do right here is we're trying to say, okay, the timer, if the timer's done, there's no level, there's nothing in there, you want to open up the input valve. So in this case, what we'll say is we want to transition states and allow this to happen. So we can say once this timer is done, so we come up here and index our, let's just move, actually let's move this down here so it's easier to see too. So what we'll do is we'll come in here and have a branch level and come over here and do the fill timer along with the start light. Well, we don't need the start light at that point anymore. See, this would happen, and that would be good. So we just need to copy the output, or the ons, to be able to transition states. And then the next state we will want to be in, so this fill timer, so that once the fill timer is done, instead of using the fill timer bit, what we want to do is we want to use the next bit in here. So we'll transition to step 2, and if you recall, we want to come back in here, and this would be step 2. So what happens in step 2, let's just collapse this down, collapse that down to, and then come over here and look at the current state. So in 1, we're going to transition to 1, right? In 2, the bit we're going to use, and we'll show you this right here, we're going to come down here and be using bit 1. So in the state, we'll use bit 1. And so what we'll do is we'll have this timer, we'll call this, let's just do this right here, come over here, add this in here, and we'll then come into here and give a, so this would be state 2, so we want to call this state 2 input valve open. We can do that right there and have that just like that. So now that kind of gives us a very clear indication of what's going on. We come down here, everywhere that done bit's being used, we can use that right here, and we can keep this really simple with what we're doing. So for instance, like right there, and we'll keep the timer, we'll remove the timer right there, and we'll go ahead and look at this, make sure that we're 100% correct. So we're actually going to use a lot less steps than what we were using, but that's fine. We do need to have the impeller working. So what we'll do too is we'll have this input filling. We remember we replaced that bit, so what we want to do is drag this up there and use that in opposite state. Make sure that that's working the way that is supposed to work as well. Again, so all this is working off the SQO, and using the states that we currently have, or basically in this functionality, I'm using it as a state, if you would. So at this point, we can look at the tank level. We can say, okay, if the start timer is there and it's good, and then we have the input off, input valves off, the discharge delay. Let's see, you can use the discharge delay timing, and we want to run the impeller. So in this atmosphere, what we want to do is come over here and say, well, if the tank level is greater than, we'll copy this and say if the tank level is greater than the set amount, which is 2,500, what we want to do is we're going to start the impeller. And we'll keep this, we'll simplify this a lot easier. So what we'll do is we'll come over here and add this in here as well. We'll give it a little branch, make that branch right there, and we'll paste this in here. Come over here, paste this there, come over here, and this will be actually 2, I'm sorry. So we want to make sure a couple things happen though. We want to make sure that this is right here is good. We want to make sure the output is not on. We want to make sure the input's not on. So we want to make sure the input's not on. Which, according to our control, shouldn't be. To be honest with you, we really don't care about the discharge delay, even though we can use it, but for this sake we're not. And then what we'll do is, so now this will transition to the next state, which is 3. So we have 1, 2, and 3. This third rung will be 3. And if we look in our tags, we can easily see what are we going to be using for this right here. We'll collapse this and then come over here, open this. Again, we're using binary coded decimal, so we're going to use this bit right here, which is 2. So in our state, we're going to be using 2. So for this, we'll get rid of this. And then we'll come over here, add a rung, or add a bit right here. And we'll say this is state 3 propeller run. Okay, so the propeller run, we're going to make sure that that state is there. We're going to alias it in there. Again, we no longer need this. So what we'll do is, once the impeller has reached its actual time, we'll come over here and we'll transition to the next stage, which is going to be the discharge. Okay, so we'll come up here, back up here, come over here and add another level, and then say come over here and paste that in there. Let's just say this is the propeller timer. So we want to say if the propeller timer is done. So if the propeller timer is done, and we'll come over here, throw this in here. This is very simple controls, to be honest with you. I know a lot of people make the SQO kind of really complex and stuff like that, so this is just the reason why I'm not doing that. So this is going to transition and make sure that that goes to another state. And the next state, again, so we have currently we have state 1, 2, this is 3, this is 4. Oh, so in 4 we can come down here and start controlling. We're going to get out of the propeller run, and we're going to come over here and open the discharge. And we're going to say, well, we're going to close the discharge as soon as the tank equals 0. So realistically, all we have to do is come over here and come back to the next state that it would be in, and this should be state value of 3. So we'll go ahead and collapse that just to verify that what we have, and then come over here and pop this open and verify that that is bit 3. It is bit 3, and this just makes life that much simpler because, again, we're using binary coded decimal. So, and this is again state 3. Now we could have changed the naming culture and stuff like that, but we'll just get rid of this. We'll get rid of this, this, and come over here and put a bit in here. This is state 4. State 4. And this is going to be state 4 outlet valve open. I'm just giving these short names and stuff like that. It doesn't really have to be anything really complex. We want to keep this. So again, once the tank is actually empty, if you would say, so once the tank is empty, the command will go to 0. We're going to control that with the actual, we're going to control that with the SQO though. So let's think about this for just a second. So we'll come in here, we're going to say state 4, we're going to open the valve after X amount of seconds. We're going to open it. We're going to say as long as it's we can put protection in here if we want to. It doesn't really hurt anything, and keep that like that. I think that's pretty much a smart move. But we need to come in here and transition to once it's empty. So we come over here, we'll copy this and come over here, copy this, and what we want to do is say if it's in, we want to drag this down here and say outlet valve. The outlet valve's open, it's in state 3, then we want 100%. We're not going to change our output valve percentage, but we will come in and change this so if it's less than this number. Actually, let's just see if we need that. With that said, we can come over here and transition that out. So realistically, we're only going to use 4 stages, and then after the 4th stage it should reset. So let's see what we got so far, and we'll change this to 4 instead of 6 because we really don't have anything. And that counts 0, so let me see, that's realistically 5. So let's see what we got here. Again, we're all subject to make mistakes, so that does happen. Okay, so we're coming in here, we're filling. We're going to fill to a certain, right here to the, actually, everything transitioned to state 2, open valve, which is pretty quick because obviously, you know, I mean, you couldn't see the rest of it, but as soon as we hit the start, this fill timer happened. And as soon as the fill timer happened, it transitioned. And we can see that again if we want to. But we'll go ahead and we'll watch the process run, and then we'll go ahead and fix, you know, look at it, fix it, whatever we need to do as far as that goes. Just keep in mind, you know, we changed the way the regular ladder logic was, so we do need to do our testing and do our due diligence behind all this. And that's just part of, you know, what you do when you reprogram something or you're programming something to begin with. You want to make sure you do it 100% as per design. You know, make sure you do it the way it's supposed to work. Make sure it's functional, make sure it's reliable, and make sure it's user friendly for the operator. In this focus, we don't have an HMI or nothing like that, so we're not really concerned with that. So come over here, we're still going to change our valve. So we did change our valve command right here, so we kept that simple. We could have had a state change on that if you would, but we chose not to. We're just going to say, okay, well, as soon as it hits 2500, right, we're going to go ahead and transition to the next state. And currently we're in position 2, and that's in position 2. So now we're going to do the impeller next. As soon as it's okay, so the impeller came on, so now that is running for 1 minute. So we're going to run the impeller 1 minute, and as soon as that 1 minute expires, we're going to transition to the next state. And the next state will be 4, and I think I'm probably going to have to change that a little bit, but no worries. We'll come over here, and that's what we're testing for. So far so good, everything's functioning the way it should. It's the question of, will the SQO reset the way it's supposed to reset according to the way we have it programmed. And the way I see it right now, we're going to transition. It's going to go to 4, and it's not going to go to 5. But what we can do is we can say, okay, copy this, put this in here, because I have a pretty good feeling about what's going to happen right here. We're going to say right here, if it's less than that, we're going to come over here, copy this, paste, and we want to come over here and put 4. But obviously, we want to make sure that the light is on too. And we want to make sure the discharge valve is not on. So we want to make sure we paste that in there. Discharge valve's not on. And that's just to get it from 4 to 5. So right now we're discharging. We're coming in discharging. As soon as we discharge and get to a certain point, we're going to come in and should transition to 5. Where I don't believe we're actually doing anything in 5, so I may have to shorten this up to 4. Not a big deal though. And then it should reset. Now, providing the start, again, we shouldn't transition anything, because we have to actually stop the system and restart it. And that's just because of the way we have it programmed right now. So let's see what this does though, just to kind of get a little bit of clarity. Because the start push button light is already on, and the ons for that, the one shot is already on, so it should not transition. Okay, so as soon as we get down to 0, so we get down to 0, and right there, that transitioned to 5. And so we should be good with that transition to 5. And if we stop right here and we start again, that goes to 1, comes back, and we are starting our process again. So looks like this is the way we have. So we got 5. Currently we have a length of 5 in our SQO, and we're using let's just say we're using 4 states right here. And that's the reason I alias them, so that you can see them, because realistically system started should be, let's change that to state 1, and we'll call that system started. And now it looks a lot cleaner. It's easier to understand. Somebody behind you can easily tell. So what we'll do again, and we still have all of our system up here. So all of our stop buttons, push buttons, and all that stuff. The only thing is, what we're going to have to do is, if we hit a stop button right now, we'll have to do like a little recovery. But in the sake of what we're doing, you know, this video is already like 32 minutes long, so we're going to keep it simple. Instead of having some recovery, instead of, you know, programming another 15-20 minutes for recovery, we'll just keep this in mind and make sure everything's going accordingly. Again, when it comes down to it, that's what these one shots are here for. But if I hit the stop button and this does one shot, it's going to one shot that back over again. So just keep that in mind. So that's why if I do stop it or e-stop it, it will e-stop the system and it will stop the system. But when I go to restart it, it may start in a different phase. So we would have to keep in mind of how do we recover from that, right? And it's not a big deal. We can write recovery logic, but for the sake of what we're doing in this video, it's just that much simpler to keep it the way it is. So again, we have converted the system over to an SQO. We do know that there is a little loophole that we need to fix. Not a big deal though, functionality wise. Again, we can fix it. As far as like if I hit the stop button right now, it's going to skip the mixing. And I know that because it's just going to right here. I know that right here because right here it's going to index. So then right here, as soon as I hit the start button again, it's going to index. And there we go. So it's going to start draining right now. So we skipped that the rest of the impeller just because of the way it's written. Again, we can write in recovery logic, little memory logic and stuff like that to prevent that, to know exactly where we're at inside of that system. But again, for the sake of what we're doing, we have accomplished our goal. What we want to do is come back and we can actually add that a little bit later. But again, we're already over 30 minutes into this video, so I just want to make sure that everybody has a clear understanding of how the SQO works, the array, pointing to it, using it as a state machine if you want. You don't have to. You can use it as like basically you control a lot of different things. Like I could in the very first step or very first position of the SQO, I could have controlled a lot of bits. I could have controlled in the second one I could have controlled different bits. It's very simple, or some of you even the same bits, right? I'm just keeping this as simple as possible because it kind of gives you a really good clear perspective. And again, that's the goal behind some of these videos is letting you know, how does this instruction work? What can I do with this instruction? What can I do to have this functional into a system? And again, like, just let this be like an eye-opener of things you can do, nothing written in stone of how you should do it, but just as this is the way this instruction works. We just took a system that was written in standard ladder logic. We made it a SQO, which is basically a sequencer, right? We made it a SQO, and then we come in and we started and had it as the sequencer. Now again, just like I just said, we still have to make recovery logic. Not a big deal. It's very, very simple. But everything does one batch and then it stops. One batch and then it stops. One batch and then it stops. So rightfully so, the operator can start his batch and walk away from it and do something else, come back, start another batch, and then walk away from it, start it. So therefore, it is doing its job. We just need to write a little bit of recovery logic for that to make sure that the sequencer stays in the proper sequence as far as where it's at and what it's doing. And maybe I'll come back and do that in a different video. But this video, I think we've accomplished our goal by making this batching system work just by simply converting the ladder logic to an SQO. So again, hopefully you learned a lot from that video. We'll see you guys on the next one.